Hi, I am Melanie Sklar. I'm a third-year PhD student working with Yejin Choi and Julia Tsvetkov in natural language processing.
My name is Kyle Johnson. I'm a PhD student in computer science and engineering at the Allen School, and my advisor is Vikram Iyer.
My name is Athar. I'm a fifth-year PhD student at the Paul G. Allen School. My research area is broadly human-computer interaction, and particularly the intersection of accessibility, visualization, and personalization.
My name is Esther Jang. I'm a fourth-year PhD student in the Information and Communications Technology for Development Lab.
I'm Jiafei Duan, a first-year PhD student at the Allen School. I'm part of the Robotics State Estimation Lab and Ranjay Krishnan's lab.
This is a great moment to be doing NLP research. Things are changing very rapidly. I focus specifically on reasoning of large language models. One type of reasoning that current large language models don't do very well is theory of mind reasonings. A short story that people usually use to test theory of mind capabilities is called the Sally-Ann test. Say Alice and Bob are in a room where there is a basket and a box. Alice has an apple here. She puts it in the basket and then leaves the room. Now, Bob will come and moves the apple from the basket to the box. So the questions that then will ask either a person or a model to probe their understanding of theory of mind reasoning is as follows. Where does Alice think that the apple is? Where does Bob think that Alice will be searching for the apple when she comes back? Where does Bob think the apple is? And those questions do not all have the same answer, but language models will always answer box. The reasoning that's missing is understanding that what you may know might not match what I know. So we'll have several graphs. For example, one graph that says, where will Bob search for the apple? So the beliefs that Bob have. Another graph for the belief that Bob has about Anne's beliefs. So this is what you feed to the language model, and we find that by doing this procedure, you can improve the performance on a theory of mind dataset.
What drew me into robotics was just how interesting it is to be able to make something that can move on its own. And the idea with the microflyer was to take advantage of these small electronics that we've been able to fabricate in the lab in order to control how it dispersed on the way down. So our origami microflyers here were actually inspired by leaves like maple leaves that have similar falling behavior. So in one state, it's flat and it tumbles really far away from the original drop location, but we can control the transition without having a battery, all while it's in the air. And in this state, it's the stable state or transition state, and it actually falls like straight down. And controlling the two states allows us to control how far away these devices float in the wind from the drop location. These things could be used for environmental monitoring, anything from climate change to even monitoring different insects.
Our research found that people who use screen readers extracted information about 62% less accurately compared to people who don't use screen readers, and spend about 211% more time on the visualizations compared to anyone else. Obviously, that's an inequity issue. So we created a software called Voxlens that makes those data visualizations accessible to people who use screen readers. How is Texas versus Florida?
I understand you're looking for value. Found the following possible results in the data. Cases for Texas is 6,498,687. Cases for Florida is 5,767,014. Cases for Texas is greater than Florida.
Our recent findings were that using Voxlens, screen reader users were able to extract information about 6% more accurately compared to people who don't use screen readers. The essence here is that if we provide them with the right tools, they're able to extract information just like anybody else.
Community networks are owned and operated by local people who are using the networks, which allow a single base station to be deployed in a small rural village to provide cellular service to the entire village. Currently, we're working on a Seattle community cellular network because even in urban areas, we have people who are low income and have trouble paying for internet access or don't have good service. We'll be mounting cellular equipment on the roofs of the organizations that we're partnering with in order to relay internet service from one rooftop to another, which will connect back to the UW fiber infrastructure and ultimately to a core internet router in downtown Seattle.
I really like the idea of having our own personalized robot butler that's able to perform everyday household tasks for us. So in my research, I look into developing scalable and intuitive approach for collecting large-scale robot data that's able to train such a robot in our own home.
So the Allen School for NLP is like the holy grail. It has a lot of people doing great work and very diverse work too. Not only that, but also we get to collaborate quite often with other institutions. So it's a big place to be doing AI.
I'm also the co-founder of Avella, a vision for engineering, literacy, and access. Avella targets underserved youth in the Seattle area, predominantly Black, Hispanic, and Latina youth. The Allen School has actually helped fund the Africatown Community Land Trust. They have the William Gross Community Center, which is like a local makerspace down near the Central District, where we've been going and teaching classes each quarter. Hopefully together we can help impact the next generation of K through 14 students.
So UW is the best place to be at for accessibility research. There's so many great professors here. There's so many great students here working in the area of accessibility. The quality of the work is amazing.
Working on community networks is so holistic because you get to talk to people in whatever communities you're working in, and everyone wants internet access, so they're always super excited about the project.
The reason I decided to join the robotics lab here at the Allen School is because I've heard many good things that come out from the research here. And not only that, we receive a huge amount of support from the faculty and from our industry partners.
My name is Melanie Sklar.
My name is Kyle Johnson.
My name is Athar Sharif.
My name is Esther Zhang.
My name is Jiafei Tuan, and I'm CSE.
I am CSE.
I am CSE.
I am CSE.
I am CSE.